Welcome back, my friends. It's time for another video about IM3. In particular, we're talking today about the binomial theorem. Well, we're going to learn how to expand the binomial. And there's a lot of technical explanations that people like to use. I'm going to try to keep that to a minimum and really just show you how to properly proceed on expanding the binomial. First of all, a binomial means there's two terms, binomial. And expansion just means that we're going to multiply it out. So when I say binomial expansion, that's what I mean. For this particular problem says, well, ask for the first term in the expansion. We're actually, I need to go over the entire method first, and then later on we'll talk about how to find a particular term, although probably not in this video. We'll save that for the more advanced methods. But for now, we're going to go over the basics of the binomial theorem and how to expand. So the first thing you do, I wrote the steps up here, is to write the row from Pascal's triangle that corresponds to the exponent of the binomial. So I'm going to assume that you're somewhat familiar with Pascal's triangle, but basically it goes like this, where 1 starts at the top, and every number after that is just the sum of the two numbers below it. And so for us here, all we care about is row 5, because row 5 is the exponent of the binomial. Is the exponent of the binomial that we're being asked about. So that means 1, 5, 10, 10, 1. So I'm going to write 1, 5, 10, 10, 5, 1. And we have to leave some space between each one because we're going to fill that with a bunch of stuff, and hopefully it won't get too squished. But that's what step 1 is. Okay, so write the row. That's what we did. Step 2, write the two individual terms from the binomial next to each other, as in a multiplication, and next to each number from step 1. So in this case, we have a plus b. So that means I'm going to write a and b, 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 and a and b. Although you do kind of want to leave a little bit of room between the a and the b so that the exponents can fit in there. So that's what this is right here. And sometimes I like to put a little multiplication sign here. It's not necessary, but I found that some students get confused about what we're doing and what this is all about. And I just have to gently remind them, we're multiplying these, because this is all just a big multiplication thing. So we're multiplying them. Then we're going to write the exponents, okay? So the exponents, and it says the left term in descending order from the given exponent. So in this case, the given exponent is 5. And so what I'm saying is that on the left variable, or the left monomial, we're going to write the given exponent, 5. And then on each successive one on the left, it's in descending order. So that's 5, 4, 3, 2, 1, all the way to 0. And then for the other one, you go from 0 up. And so that's what it means here in ascending order, starting from 0. So here's a 0, 1, 2, and I apologize for my handwriting there on the 4 and the 3, 4, and 5. Then we're going to write the signs. So in this case, it's plus, so it's easy. These are going to be all plus. So I'm just going to put plus here. If it were negative, we're going to see an example on that later. But if it was negative, we'd have to alternate. So it'd start with a positive here, and then negative, positive, negative, positive, negative. It would just alternate. But we're not dealing with that right now. And then we have to simplify. Okay, so simplify what? Well, these coefficients, for example, like having a 1 in front, not really necessary. Having a term that's to the 0 power, that also doesn't do anything. Well, then why did we do it in the first place? Well, it just helps having a consistent, repeatable method that's easy to follow for people. And so I like to have them do that, because otherwise they skip things and miss things. And it's just easier to do it in this order. And then, of course, little things like having an exponent of 1, these things aren't necessary either. And so what that gives us is a to the 5th. And simplifying might also mean like multiplying coefficients with individual constants from the terms that might have occurred. A to the 5th plus 5a to the 4th b plus 10a cubed b squared. And again, none of this is really necessary if you just want the first term, because that's just a to the 5th. But we're just expanding out. So plus 10 times a squared b cubed plus 5a b to the 4th plus b to the 5th. And that's it. And that's how you expand a plus b to the 5th power. This right here equals that. And so that concludes our basics video. We'll keep going with some of the more advanced ones. Thank you very much. Please like, share, and subscribe. See you next time.